In this video, I am going to show you how to work with imaginary numbers and complex numbers. So I is square root of negative 1. Okay, if you square the I, you have to square the square root of negative 1. So I square is the same as negative 1. So when you take square root of negative 1 square, you get negative 1. Now I is an amazing number. It is the only imaginary number. However, when you square it, it becomes real. As you can see, I square is negative 1 and negative 1 is a real number. So of course it wasn't instantly created. It took many years to convince certain mathematicians to accept this new number. They even thought a section of numbers called imaginary was created, which also includes complex numbers, which are numbers that have both a real and imaginary part. And people now use I in everyday math. So I was created due to the fact that people simply needed, at first, solving problems such as square root of negative 25. Okay, so when you take square root of 25, you get 5 because 5 times 5 give you 25. But if you try to take square root of negative 25, it's not possible because it's not a real number. Okay, because we know what I is, you can break square root of negative 25 down using square root of negative 1 times square root of 25. Okay, so now square root of negative 1 is an I, and then square root of 25 is 5. So this becomes 5i. It also needed because if you would try to solve x squared plus 1 equals to 0, okay, it would be impossible because you end up taking square root of negative 1. Okay, so that's what makes it impossible. Okay, because square root of negative 1 is not a real number. However, mathematicians soon came up with the idea that such number to solve this equation could be created. So today the number is square root of negative 1, more commonly known as I. It is a good thing that scientists, mathematicians who didn't want a new numbers created, and other non-believers finally allow I in the number system. So today I is very useful to the world. Engineers use it in their study all the time. Complex number help them study the flow of fluid around objects, such as water around a pipe. Complex numbers are used in electric circuits and help in transmitting radio waves. So if it weren't for I, we might not be able to talk on our cell phone or listen to the radio. Also help in study infinite series. And then lastly, every polynomial equation has a solution if complex numbers are used. Clearly, it is a good that I was created. So here I'm going to show you what a complex number is. Okay, so a complex number can be written in the forms of a plus bi. Okay, so where a is real and then b is also real. Okay, so those are real numbers. And I is the imaginary part. So therefore, a complex number contains two parts. So one part is real, so the A is the real, and then the other part is the imaginary. So the BI is the imaginary part. Okay, so an example of a complex number would be 2 plus 5i. Okay, so even though complex have an imaginary part, there are actually many real life applications of these imaginary numbers. Okay, so they use these types of numbers in electronics and in electricity. Okay, they use them in electronics and electricity. Okay, so now we're gonna get into simplifying imaginary and complex numbers. Okay, so let's take a look at the first one. Okay, so here we're going to simplify I to the 19th. Okay, so what is I to the 19 in simplest form? Okay, well, in order to do this, you need to know the value of I square because we have to reduce this using I square. So you have to know that I square is -1 in terms of real number. So again, I square is -1. So how do we simplify this using what's given to us? Okay, that I square is -1. Well, what you want to do is you want to break this up using I square. If you break this up using I square, okay, I square 2 cannot go into 19. Okay, so you want to break up the 19 using a number that 2 can go into it. Okay, so it's best that we break up using I to the 18 times I, okay, to the first power. When you multiply these two powers, and you know that when you multiply powers, you add the exponent, so this is now I 19, right? Okay, we can rewrite I to the 18 using I square. Okay, so that would be I square, and then 2 goes into 18 9 times. And then you can check, I mean, right here you have power raised to another power. How do you simplify this? Well, you simplify by multiplying power. So this is I to the 18, as you can see, okay? And then bring down the I. We replace I squared with -1 because we know that, so the value of I squared is -1. And then -1 to the 9 power. And then bring down the I. Okay, so what is it when you raise -1 to the 9 power? Well, because it's an odd exponent, right? You got to take -1 times -1 for 9 times. So because of it, it's going to come out to a -1. And then bring down the I. And then when you multiply those two, you get -1I or just -I. So I to the 19 power is the same as -I, okay, in simplest form. All right, so let's take a look at another one. How about we simplify I to the 82? And we're using I square, okay, I square is -1. Okay, we're going to use this information to simplify I to the 82. Okay, so 82 is an even number. Okay, therefore you do not have to break this up because 2, okay, since we're using I square, 2 can go into 82, right? I square, okay, so 2 goes into 82 how many times? Well, that would be 41, right? Okay, because 2 times 41 is 82. Okay, and then I square, we replace that with -1, and then that to the 41st power. Okay, so -1 to the 41st power is just going to be -1. Okay, so I to the 82 came out to -1. So here we are going to simplify. Okay, so -5I, and we're going to multiply that with 2I, that whole thing square. So here we got the two operations. We have multiply and then we have exponent. Okay, so you got to get rid of the exponent before you multiply. So we're going to leave the -5I alone for now. Okay, so when you take 2I square, it's the same as taking 2I times 2I because of the square. Okay, so when you multiply, you're going to get 4I squared. So this whole thing is 4I squared. Okay, or you can just go, look, 2 square, right? 2 square is 4, and then I square is I square. Here we have an I square, so we know what I square is, right? I square is equivalent to -1. Okay, so we're going to replace that with -1. So here we have -5i times, so here it's going to be 4 times -1. So that's going to give you -4. Okay, and then when you multiply the two numbers, you are going to end up with positive 20i. Okay, so the whole thing is going to be positive 20i. So again, imaginary and complex numbers. This time we are going to simplify square root. Okay, so let's say we take square root of -8, and then we're going to multiply by that with square root of 6. Okay, so you're multiplying two square root. Okay, you're able to do it because they both have square root. Okay, so when you multiply here, you're going to take -8 times 6. Okay, so that's going to give you square root of -48. Square root of -48 is not a real number. And also, 48 is not a perfect square. So we're going to have to break down 48 using a perfect square, the largest perfect square that can go into 48. We're going to take this out. So we're going to use square root of -1, right? Because we know that's going to come out as an I. Okay, so we're going to break down 48 using 16 and 3. So we're going to take square root of 16 times square root of 3. That's going to give you 48. We're using 16 because 16 is the largest perfect square that can go into 48. Okay, so we don't have to break it down again. Okay, because if you don't use the largest perfect square to break it down, then you're going to have to do it again. You always want to use the largest perfect square to break it down if it's not a perfect square, because this way you only have to do it one time. Okay, so square root of -1 here is going to come out as an I. Square root of 16, that's 4 because 4 times 4 is 16, and then square root of 3 stays the same. So here, if we multiply everything all together, we're going to get 4i, because I times 4 is 4i, and then square root of 3. Okay, so next, we are going to simplify these two complex numbers. So you got 10 plus 15i. So this is a complex number. And then we're going to minus another complex number, which is 48. Take away 30i. So when you are adding or subtracting complex numbers, you can only add the real with the real and then the imaginary with the imaginary. So here, if you look, this is the real part. Okay? And this is your imaginary. So the 10 is the real and the 48 is the real. Now you're going to take 10 minus, because you get the minus here, 48. So what is 10 minus 48? Well, that's going to give you -38. Okay, so we're done with those. And then the imaginary, the 15i and the -30i. Okay, so now you're going to take 15i minus -30i. So that would be what? 15i plus, right? Because you got, when you minus a negative, turns into a plus. So that's going to be plus 30i. So when you add those two numbers, you're going to get 45i. Okay, so let's take a look at another one here. So we just did subtraction, complex numbers. Now this one is multiply. Okay, so you got a complex number here, multiply with another complex number. Okay, we're going to use the distributive property to multiply these two complex numbers. So first thing you have to do here is take 4 we're going to distribute the 4. So you take 4 times 2, and then 4 times negative 5i. Okay, so 4 times 2 is 8. And then 4 times negative 5i is negative 20i. And then you're going to do the exact same thing with the 3i distributive property. So 3i times 2, and then 3i times negative 5i. So 3i times 2 is 6i, and then 3i times negative 5i is negative 15i squared. Okay, so that's the first thing you have to do. Get rid of the parenthesis by multiplying using the distributive property. So now we're going to combine like terms. Here you have negative 20i plus 6i. So that is going to give you negative 14i. And then bring down the negative 15i squared. And then here we have I squared that we know the value of it in terms of real number. Okay, so I squared, we went over this earlier. We know that I squared is the same as negative 1. Okay, so we're going to replace I squared with negative 1. So we have 8 minus 14i minus 15 times negative 1. As you can see, I am replacing I squared with negative 1. So here we have 8, take away 14i. Okay, now when you take negative 15 times negative 1, it's going to give you positive 15. Okay, so you can combine the real number with the real number. So 8 plus 15 is 23. And then bring down the negative 14i. Okay, so here we have 6 minus 7i. So that's a complex number. And we're going to square it. Okay, so how do you simplify something like this? So when you square something, you are multiplying by itself. For example, let's say you have 9 squared, right? Isn't that just 9 times 9? Okay, so when you square something, you multiply by itself. So here I have 6 minus 7i squared. So that's the same thing. When you rewrite that, it's going to be 6 minus 7i. And then times 6 minus 7i. So we know how to multiply complex numbers because I explained to you how to do that in the previous example. So here we're going to distribute, right? So we're going to distribute the 6. So 6 times 6, and then 6 times negative 7i. So that's going to be 36. Take away 42i. Okay, and then we're going to do the exact same thing. Distribute the negative 7i. So negative 7i times 6, and then negative 7i times negative 7i. So here's going to give you negative 42i. And then negative times negative is positive 49i squared. Okay, now we're going to simplify. Bring down the 36 for now. And then these two are like terms because they both have I. So when you combine those, you get negative 84i. And now here, we know that I squared is negative 1. So when you take 49 times negative 1, you're going to get negative 49. Okay, and then you combine the real with the real number. So 36 goes with negative 49. That's going to give you negative 13. And then bring down the 84i. Okay, so this is your final answer. And that's how you square a complex number. Okay, so next we're going to get into simplified complex numbers. Those numbers that are rational numbers. Okay, so basically you have a fraction that you have to simplify. So this is an example of a rational expression that has complex numbers. Okay, so we're going to simplify this, and we have a procedure that we can use, and we're going to go through it step by step. Okay, so let's take a look at step 1. Okay, so first thing we have to do is find the conjugate. Okay, so to come up with the conjugate, it's the denominator with difference between the two terms. Okay, so here's your denominator. So the 6i is your denominator. Okay, so the bottom is your denominator. So that's 6i. Think of this as 0 plus 6i, right? Because 0 is the real number. So the conjugate here is going to be 0 minus 6i. Okay, so it's going to be 0 minus 6i. Okay, so that's step 1, is to come up with the conjugate. Okay, let's take a look at step 2. Okay, step 2 is to multiply the numerator, which is the top, and the denominator, which is the bottom, by the conjugate. Okay, so the conjugate is 0 minus 6i, so we're just going to multiply the top and the bottom. So 0 minus 6i is just going to be negative 6i. Okay, negative 6i. Okay, so we're multiplying the top and the bottom by negative 6i. Okay, to make it easier, look, you can cancel out the negative 6, see it? So negative 6 over negative 6, they cancel out. So now you're just left with I. So this way, you're making the number smaller, and it's a lot easier to work with. So now we're going to take 18 times I, and then negative 8 times I, right? Because that's all we have left is the I. So 18 times I is 18i. And then 8 times I is going to give you 8i squared. So that's your numerator. Okay, so that's what you get for the top. And then for the bottom, you're just going to take 6i times I. That's going to give you 6i squared. So step 3 is simplify if needed. So we do have to simplify because look, you got I squared that you have, that you know what the real number is for I squared. I squared is equivalent to negative 1. So you're going to replace I squared with negative 1. So now we have 18i. So here when you take 8 times negative 1, you're just going to get negative 8. And then your denominator is going to be 6 times negative 1 is going to give you negative 6. We're going to reduce it, right? So it looks like you can reduce all these numbers by 2. 2 can go into all of them. So 18 over 2 is 9i. 8 over 2 is negative 4. And then that whole thing over negative 3. Okay, and then you can get rid of the negative at the bottom by doing this. So it'll be negative 9i plus 4, and that whole thing over 3. So when you're simplifying complex numbers that are fractions, okay, your goal is to get rid of the I in the denominator. All right, so you have an I here. So what we did is we eliminate the I by doing this. Eliminate the I at the bottom. Notice there's no more I at the bottom. Okay, so let's take a look at another one here. Okay, simplify complex numbers that are rational numbers. So fraction here, we got to simplify. So we have to get rid of the I that is at the bottom. Okay, and we have a procedure that we can use to simplify this. Okay, so first thing we have to do is find the conjugate. And to come up with the conjugate, it's the denominator with difference between the two terms. Okay, so your denominator is 8 plus 2i. Okay, so your conjugate is going to be 8 minus 2i because it's the different. Okay, so that's your conjugate. So step 2 is to multiply the numerator and the denominator by the conjugate. So our conjugate is 8 minus 2i, so we're going to multiply by 8 minus 2i to the top, and then 8 minus 2i to the bottom. Okay, so there's going to be a lot of multiplying here. Okay, so first thing we have to do here for the numerator is distribute the negative 3. So when we do that, we get negative 24 and then plus 6i. And then you're going to do the same thing with the negative 4i. Negative 4i times 8 and then negative 4i times negative 2i squared. So it's going to give you 32i and then plus 8i squared. Okay, so that is your numerator. We're going to come back and simplify it after we multiply the numerator and the denominator. Okay, and then for your denominator, this is the conjugate of this. You can save time by just multiplying the 8 with the 8 and then the positive 2i with the negative 2i. Because if you were to do like you did up top, okay, the second term and the third term, they're just going to add up to 0. All right, because look, you got negative 16i with positive 16i. Okay, because the opposite, they add up to 0. So you're just going to get 8 times 8 is 64. And then minus 4i squared. Okay. And then the last thing we have to do is to simplify. Okay, so for our numerator, we got negative 24 minus 6i minus 32i is negative 26i. And then here you got 8 times negative 1, right? Guys, 8 times negative 1 because I squared is negative 1. So that's going to give you negative 8. And then your denominator is going to be 64. So here negative 4 times negative 1 is going to give you positive 4. And as you can see, there is no more I in your denominator. Okay, so to finish this up, negative 24 goes with negative 8. Okay, that's going to give you negative 32 minus 26i. And that whole thing is going to be all over 68. Okay, so can we reduce it? Okay, so let's see. Can you think of a number that can go into 32, 26, and 68? How about we break it down by 2? Okay, so we reduce by 2. 32 over 2 is half of 32 is 16 minus 13i. And then it's going to be all over 34. And that is your final answer. And that is how you simplify complex numbers that are fractions. Okay, so I hope these examples are helpful. Okay, I want to thank you guys for watching this video. Okay, so please help share and subscribe down below. And I thank you so much again for watching it. And I'll see you guys in the next video. Thank you.